Yes, I can. Thank you.
Perfect. Okay.
What's up, D-Ward?
Hello.
Is Eric on today?
Yeah, no, sure.
Okay.
Ward, how's the whole life today?
Oh, just lovely.
How you feeling?
I feel fine. I just don't have any sense of taste. Not doing well. Coughing really badly. He might have to actually go to the ER today.
So are you eating healthy foods now since you can't taste them?
Yeah, I just eat pretty much nothing anymore because there's no point. And the only reason I drink soda or coffee is because I need the caffeine, otherwise I get a headache. But I don't taste anything. It's the weirdest thing in the world. I put mustard on a sandwich today just because I can't taste it anyway.
Mr. Ward, you should download TikTok and make those TikToks where you're eating like weird foods but you can't taste them.
Yeah, I should.
Yeah, you eat it raw. You eat it like raw or like a garlic clove.
Okay, so what do you... So, we miss anyone other than Erica?
Just Erica.
Okay, perfect. All right. Well, thanks for being here, guys. Let's take a few notes. I'm going to give you some time where you can work on your assignment today. You have an assignment due tonight if you have not already turned it in. The only thing that will come to you today via Google is a question of the day, just a single question. We'll get homework probably tomorrow, a new assignment. Today I kind of warned you, it was just going to be a chain rule, kind of an intro day. We've already had chain rule before, so it's one of those things I just want to kind of review it with you. So make sure that you are taking notes today. We are going to do some pretty intense problems with chain rule today. So my goal is to do about 2 or 3 problems. We're going to start with something kind of easy to review what it is, and then we're going to work our way to kind of just an excessively difficult problem. So that's what we're looking at today, and you can see the rules in front of you. But yeah, we're just going to take a few notes. Tomorrow we'll probably get an assignment, something short, 4 to 5 problems that you have to take the derivative of it. They're not going to be easy, so kind of figure that out. So let's just review chain rule before we begin, and then we'll get to the more difficult problems. So chain rule here is where you have some function with another function on the inside of it, like that. So it's like a composite function, something inside of another object. When you take the derivative of it, you take the derivative of the outside, so that means you drop the power out front and subtract 1 off the power. Then you're going to take it times the derivative of the inside. That's the chain rule. That's the formula to find the derivative. So whatever this is, maybe this is y and this is y prime. This is the idea that I want to cover today. We're going to start with an easy one and kind of work our way to that challenging problem where you have to find the first derivative. So I want you to take notes. Keep these in your notes somewhere. You're going to need them for the homework that you're eventually going to get tomorrow. You all have a challenge question of the day. I just want you to attempt it, just to try it. It's just a question to see if you guys are paying attention. So it's just one. It's in Google Classroom. So, but that I think it will go live in about 10 minutes or so. All right, let's jump right in. Let's talk about a simple chain rule, unless you guys have questions.
Pay attention, please.
So, all right. So here's my function. Let's go with. Okay, we're going to start with something easy first. X cubed plus 12x squared minus 4x, and this is all to the 5th power. This is a normal chain rule that we've seen before. A normal chain rule where you have something complicated on the inside and you have a power on the outside of the object, right? You could make it a product rule. You could make it, you could make it a polynomial by foiling everything out. I would not want to do that. So what we're going to do here is we're going to just take the first derivative, and then we're going to go after then we'll talk about how to do the second derivative on the next problem, right? All right, so the normal chain rule is where you drop the power out front. So on this one, the power is a 5, right? So you drop it out front, and you subtract 1 off the power. That's the normal chain rule that we normally do, right? Always subtracting 1 off it. But then you have to take it times the derivative of the inside. That's the part people always forget. It's times the derivative of the inside because you can't forget about the inside. So the inside ends up being a 3x squared plus 24x and then minus 4. Questions about what a normal chain rule is?
Nope.
Okay, good. Now, I want to talk about the second derivative, right? Because that's the whole point today, right? We're trying to figure out first and second derivatives and getting progressively more difficult. The second derivative of this thing is doing it by an actual, like, product rule. So the second derivative, when I think about product rule, if you don't remember that, that's where, you know, whatever your function is, it's the derivative of the front times the second, right? So derivative of the front times the second item plus the derivative of the second times the first. That's the product rule that we've discussed previously. Okay? I'm going to do that on this problem. This problem is a product rule. It's two items being multiplied together. Now what I'm going to do to make this a little bit easier so it doesn't look complicated, I'm going to multiply this 5 into this parenthesis back here, just so you can see that there is two distinct items being multiplied together. This looks like there's 3. The 5's out front. Technically I wouldn't need to do this, but I'm just going to do this so it makes a little bit more sense. But this is the formula I'm about to use here in a second. So don't forget that. It's derivative of the front times the second plus the derivative of the second times the front. That's the product rule in this thing. Okay? Alright. Oh, I should have left that there. Hold on. Let me take a screenshot before I erase that. Alright. Okay, second derivative. Here we go. So, second derivative. Now again, before we begin, I'm going to simplify this part where I'm going to put that 5 in the parenthesis in the back, just so this is a little bit easier to look at. So this is 50. Because I can't multiply this in the front because it has the power of 4. That would mess everything up. You'd have too many 5s. So I'm going to multiply it in the parenthesis in the back because there's only one of them. So...
Okay.
That's a 0, carry a 2, that's a 120, minus 20. Okay, is that 24 times 5? Yeah, alright. So, again, for good question, why did I multiply the 5 in the back and not in the front? The front, there's 4 of those parentheses, and if I accidentally multiply the 5 in there before I distribute the power, or, you know, multiply the parentheses out, you'd have too many 5s in the problem. So I'm going to multiply in the back. There's only one parenthesis in the back. So there's only 1 and 5 being multiplied through. Alright, but second derivative. Here we go. Alright, so second derivative. It is the derivative of the front item, which is the chain rule. That's the derivative of the front. And I'm writing it down here just so you can see this. That's the derivative of the front item. This is technically the first item, right? That's the derivative of it. Times the second. Okay, so that's the derivative of the front times the second item. And this, again, this is the second item that you're seeing there. And then I have to add... So I would add, so after all that thing's being written, I'm going to add the derivative of the second item, which the second item ends up being 30x plus 120. That's the derivative of the second item. That's the item back here, right? This is the second item. So the derivative of that is this times the front, which is this item. Again, how I'm coming up with these, it's really relying that you understand where the front and the second item is, first and second. Okay, questions with the second derivative. That's it. I'm going to leave it there. I'm not going to simplify it any further. That was the derivative of the front times the second, the derivative of the second times the first. Did I lose anybody?
Sounded pretty good.
Okay. Now, here's the crazy thing. I consider this one the easy problem. I know the derivative was ugly. I understand that. That second derivative was a mess, right? There's so many things happening there. The problem is what we're about to go into is really difficult stuff, where the derivatives are excessively large, and you have to really know your rules. You either have to know your quotient rules, your chain rule, the product rule, the sum and difference rule. You have to know all the different rules of derivatives to be able to handle a chain rule problem, where you're going like a second derivative on a chain rule like you're seeing here, where it's derivative of the second times the first, derivative of the first times the second, that type of thing. You have to know your rules. Alright. Can I move to the next one?
Yeah.
Okay. So again, I really only have 2 or 3 problems picked out. This next one is kind of the main one. This is the one I really wanted to get to today. If we want to do a third, I'll do a third, but I want to at least get through 2 of these for sure today. That way you have a little bit of time where you can finish up your homework if you did not get that assignment done for Friday. I know a lot of you did it in class Friday, so you might already be done and it's already turned in. That's great. I don't know if some of you have. Remember that assignment was quotient rule, where you want to do law of division. You want to do the synthetic division or long division first, and then once you've simplified it, then take the derivative and the second derivative of it. Makes it a lot easier. So I did a bunch of shortcuts with you the last couple days in here. So, all right. But yeah, so let's look at a chain rule, but let's look at something kind of difficult. So, all right. So let's go with the sine of 3x squared times the sine of x. This is a chain rule. We have something inside another object, and the object in the inside is not easy to look at. Okay, are we ready to go?
All good? All good?
Okay. Now this is the one I want to get to today. This is not an easy problem. This is a monster of a problem, okay? So it doesn't look bad until you actually get into the details of it. I want to try to attempt the second derivative of this thing, the second one. This could be pretty long and intense. It's going to take some serious kind of computational work here. So, first derivative, let's talk about that. Okay, so first derivative. It's just normal chain rule. So the derivative of the outside, well, the derivative of sine is cosine of the inside, right? This stayed the same. Right? Now, we have to multiply now times the derivative of the inside. Okay? So, the derivative of the inside of this parenthesis, the inside of the original problem, I'm going to highlight this in blue. This was the inside, correct? The derivative of the inside is a product rule on this particular problem. So when we multiply by the derivative, we have to use a product rule when we do it. So the product rule is, I'll try to color code this. It is the derivative of the front times the second plus the derivative of the second times the first. I'm going to try to color code so you can see what I'm taking the derivative of. So the first item is the 3x squared. So the derivative of that is 6x times the second. Well, the second item was just the sine of x. All right, if it lets me write that. Let's deal with this. Come on. My pen died? Oh man, that'd be terrible if my pen died. Oh man, this is gonna be terrible. So I'm gonna have to write with my finger. No, it's. Oh wait, did I just have an eraser? Oh, I'm an idiot. All right, I'm an idiot. All right. Okay, so sin x. Ooh, man, that was we dodged a bullet there. Okay, so 6x times sin x, and then we have to add, right? Then we add the derivative of the second item. Well, what's the derivative of sine? So it's derivative of sine is cosine of x. And then the derivative of the inside of that would be just 1, so I don't have to worry about it, times the front, which the front is 3x squared. Okay, does everyone see that?
Yes.
Okay. Now. Okay, so we're here. Now.
Bill, I lost something.
What did we lose?
We're back to after the second, or the first, where are we at after that?
Okay, are you back? Are you back here, there, Isaac? This part?
Yeah.
Okay.
No, the second part of that. The second part of that.
Okay, so just this part over here.
It's the derivative of sine. Yeah.
Okay, so this is the product rule. So it's when you do the product rule, it's the derivative of the first times the second plus the derivative of the second item. The derivative of sine is cosine times the first. So derivative of the first times the second plus the derivative of the second times the first.
This is a product rule inside. It's a product. Oh, yeah. Oh, so it's inside.
Yeah.
Yeah.
Okay. Are we good with that so far?
Yeah.
Okay. Now, here comes the monster. Okay, are you guys ready for this? This is why I said I wanted to get to this problem today. Alright. We have to find the second derivative now. The second derivative of this thing is doing a product rule again. Okay? So we're going to do a product rule. The product rule on the second derivative here, and I'm going to highlight this. This is the first item. And this is the second item. So when I start doing the derivatives here, I'm doing an overall product rule. Derivative of the first times the second, plus the derivative of the second item times the first. This is where it can be complicated, because the derivative of the first item, the part that I have underlined in red, or the part that's in green there, the first thing I underlined, that derivative looks like the one I just wrote down. It looks like that whole line that you're seeing there, the entire line all the way across. That's the derivative of the first item. It'll look the same. And then the derivative of the second item is a monster itself, because it is, it's a sum and difference rule. There's a plus sign in the middle, but it's two product rules. So that the derivative of the second item is huge, and then we'll multiply it by the first. So that's what I want you to mark. So I'm going to write down the formula so you don't get lost here. So the second derivative, what I'm about to do, because I have to do a product rule, it's the derivative of the first. So the derivative of the first times the second. If it lets me write the little n. Okay, I don't know why it won't let me write that. Plus the derivative of the second times the first. Okay, does that make sense, the formula I'm about to attempt here?
Yeah.
Because the overall rule is a product rule here. That's why I'm doing this. Okay, so I'm gonna try to keep this color coded as best I can. Okay, so second derivative here. It's gonna take me a lot of lines here, so this is gonna be pretty lengthy. Okay, derivative of the first item. That's the part I have marked in green there. I have it underlined in that thing that says first. The derivative of that thing is negative sine of the inside, and then since it is a chain rule, I have to take it times the derivative of the inside, which is this thing. Okay, what you're looking at here, that is just the derivative of the first. It is the overall outside is cosine, so that's the derivative of that is negative sine of whatever the parenthesis is, and then the derivative of the inside of that parenthesis of the first item is that 6x sine plus cosine 3x squared. Okay, does everyone understand that's the derivative of the first? All I've done so far is this piece right here. I know a lot of you are still writing, probably. That is just the derivative of this item right here. It's just the derivative of the first that I've written down here in red. What do I have to do next? Take it times the second. The second item up here, I'm going to keep this color-coded. The second item that is up here, the second item is this part that I've underlined in the black. The second item is 6x times sine x plus cosine x times 3x squared. That is the second item on the board. Okay, does everyone see that?
Yeah.
Derivative of the first times the second. Now, I put a plus sign because now that this plus sign I just wrote down here in yellow represents this thing. Now, I have to take the derivative of the second item now. So the derivative of the second item, I'm going to put this in black here. So now I'm right here. I'm at this step right here. I'm taking the derivative of the second item. The derivative of the second item, which is this colossal thing over here, is two product rules. So I'm going to put this in brackets. The derivative of the front times the second plus the derivative of the second times the first plus the derivative of the first times the second plus the derivative of the second times the first. What you're seeing there is the derivative of this monster right there. It's two product rules put back to back. Again, this part right here that you're looking at is this derivative right there. It's a product rule. Derivative of the first times the second, derivative of the second times the first. And this piece right here is the derivative of this thing, which is a product rule.
I know where you got the plastic part.
You don't?
No.
This piece right here, is that what you're questioning?
Yeah.
That's this derivative. It's a product rule.
Why are you adding it?
Because technically in the middle here, there's a plus sign. That's this thing right here. Because when you do a sum and difference rule, you just have to keep the plus sign in between them.
Product, and so you have to do it twice. The left side before the middle. I need to screw this one in my all times.
I mean, to make you feel better, I have no idea what any of this is. Not a clue.
It's been too long there, Scott.
I did not take calculus.
Oh, I thought you did. All right. And now we're going to multiply by, because I'm not done yet, I still have to multiply by the first. So the first item that goes behind this mess, this colossal parenthesis, because that was the derivative of the second item, the first item was the cosine 3x squared times sine x. And that's the part that goes back. That's that first item that I have written up there.
But this is that's a lot of work.
That is a lot of work, and I know it's tough. That's what I said. We don't get through very many problems when you do chain rule because they get so big so quickly. They can become monsters in problems. Like you thought the quotient rule was tough, and you thought they get long and complicated. The chain rule is way different. There's so many rules. You have to know every single rule you're doing, and you have to know it extremely well. You have to know the sum and difference rules, the product rules, the quotient rules. You have to know how to do a chain rule correctly in the middle of it sometimes. And that's what you're seeing here. You're seeing, I made a problem that had almost every rule in it other than quotient rule.
Mr. Ward, we have a question.
Yes.
Alright, so you know the 2 brackets up top? Couldn't you just like square one of those brackets and then it just...
Yeah, because I agree with that. This part right here, it's the same parenthesis happens, so you could just put them together and make 2 of them. Yeah, I agree with that. I just didn't want to put that there because that would have been extremely confusing. It's not going to happen that way every time, just on this one it did. So. Alright, I'm going to turn you guys loose. You guys got homework due tonight. I just want to do 2 problems today. We're going to do a couple more of these tomorrow. You do not have homework on this stuff. I have a Google question that went live today that looks like this one. So I want you just to get some taste in it. We're going to go through that one tomorrow. That's going to be my first example we're going to do in class tomorrow. So it looks just like this one. So I just kind of made it up so it kind of mimics it. So take your time, try it out today. If you don't have a lot of time, that's fine. We'll look at it tomorrow. It was just a Google question. I want to throw one out there for you to try out. So tomorrow we're gonna look at some of this stuff. We're gonna look at some pretty difficult problems tomorrow. So be ready to go. Good luck to the basketball team tonight. Wish I could be there. So good luck. Yeah, I'll see you guys tomorrow. Thank you, Miss Scott.
No problem.